Hello there. This is an introduction to the C++ learning series. In this episode, I will explain some essentials, what a programming language is, the difference between C and C++, and how this series will go. First, what is a programming language? Computers are machines that can do a lot of things, but they won't do anything randomly. You must tell them what to do for them to actually do it. For example, when you click on an application, you are telling it to open that application. A programming language is the way to tell the computer what to do. There are a lot of programming languages to choose from, and C is one of them. But wait, if there are so many programming languages, how can a computer understand all of them if they are different? The truth is, it actually can't. Computers can only understand binary. You don't need to know everything about binary right now, but you should know that it's just a bunch of ones and zeros. I know this is getting confusing, so let's explore the history a bit. In early times, people had to write ones and zeros by hand. Each one and each zero represented an instruction that the computer could do. In the early days, there weren't many instructions, so writing in binary wasn't that challenging. But there were problems. First, you had to remember each instruction number. Second, portability was an issue. If you wrote a program on one machine, you didn't know if it would work on another machine. Why is that? The thing that runs your programs is the CPU. At that time, each company created their own computers with their own CPUs. This meant each CPU had different instructions. For example, adding two numbers might be represented one way in CPU A and another way in CPU B. Code written for A would not run properly on B because B would understand something else. So people wanted something easier to memorize and something that could somehow be portable. The first language made for this purpose was assembly. Assembly is still binary, but instead of typing the numbers, you write words. Then the assembler, another program, looks at the assembly code and translates each word into ones and zeros. So it's just binary that you can read. This is why it's called a low-level language, and it's still used today. If you look at different complex projects on GitHub, you will see that assembly is used, even if only a little. Assembly fixed the portability issue. Each machine could translate the same words into numbers it could understand. Assembly at that time was very powerful, but as computers evolved, it became harder to use. In modern times, it's a very bad idea to make a big project using only assembly. The problem with assembly is that it's still binary, just in words. So you are literally writing binary. You often have to repeat some instructions unnecessarily. People wanted a language that made this easier, a language with better syntax, one where you don't repeat unnecessary things. One line of code could do what would take multiple lines in assembly. This is what we call a high-level language. Each high-level language has its own translator, which we usually call a compiler. This isn't exactly true for all languages, but we'll stick to this term. The compiler translates the language into assembly, and then the assembler translates it into binary. So it's a two-step process where each step converts the code into a lower-level language. This made life much easier. However, old high-level languages weren't perfect either. At the time, they were groundbreaking, but as computers evolved and became more complex, the old language's syntax became harder to work with. That's why people made many new programming languages. For example, Fortran, an early high-level language, is very hard to write in. Each new language often improved on the previous one. In 1972, Dennis Ritchie made a language called C, which was an improvement of a previous language called B, created by Ken Thompson in 1969. All the old programming languages eventually died out, but C was so good that it's still used today. It's literally everywhere. It's used in websites, operating systems, embedded systems, compilers, games and graphics engines. Around the 1960s, there was a language called Simula. This language had something even C didn't have: classes. You'll learn about classes later, but classes are the fundamentals of modern programming languages, which we call object-oriented programming, OOP. In 1983, Bjarne Stroustrup wanted to combine this feature from Simula, a language with very bad syntax, with C, a language with very good syntax. He called the result C++. To this day, both C and C++ are used. Now you can understand the difference between the two. C++ is basically C, but with modern features. Everything you learn about C in this series will also work in C++, even if there's a C++ specific equivalent. In other words, C code always works in C++, but C++ has additional features that C doesn't have. I will talk about C features, and if there's an equivalent in C++, I will discuss it either in the same episode or in the next one. C++ specific features will have their own episodes, so you may see C episodes, then C++ episodes, then back to C, and so on. That's it for this episode. See you in the next one, where we will set up the compiler for both C and C++ on Linux and Windows.